All I did is I entered these in, and I found SX on the calculator, and that's our standard deviation, so that's this one. And then I took this and I squared it to get the variance here. So I actually just did this one in the calculator without filling these in. Kind of cheating, but you know. This was just to see where it comes from, and the calculator is the way that we're going to do it. So the key ideas here behind the properties of the standard deviation. S measures spread about the mean and should be used only when the mean has been chosen as a measure of center. So remember, we only use the mean when stuff is approximately symmetric. So if our data is not approximately symmetric, we're not going to use standard deviation. S equals 0 only if all observations are exactly the same. So just imagine that all of these were 7.81, okay? Then you'd be subtracting these, you'd get 0 every single time. So if all the observations are exactly the same, then there is no variance at all. They don't vary at all. They're all the exact same. So if S is equal to 0, that only happens when all the observations are exactly the same. If any of the observations are different, our standard deviation is going to be some number above 0. Remember, it's never negative because we do the square of the difference up there. It makes all those numbers positive. And then S, like the mean, is not resistant. So we only use the mean if it's symmetric. So we only use standard deviation if it's symmetric, because outliers will affect it. Skewness will affect the standard deviation, just like it does the mean. So use it to describe only reasonably symmetric distributions that are free of outliers. So no skewness, no outliers, we use standard deviation.